Hello, everyone. My name is Kier von Koenigslo, and I'm a Kafka architect at GoodLab Studio. Today, I'm going to be introducing ORKA's Smart Switching Sets feature and why it matters for Kafka application development. So the core problem that we're going to be talking about is doing blue-green deployments in Kafka stream processing without sacrificing correctness or guarantees or operational safety. So the punchline here is that ORKA enables a controlled, low-impact pause to safely switch routing while keeping state warm and preserving Kafka guarantees. We'll start by framing the common blue-green deployment strategies for Kafka apps and where each one introduces its own challenges. Then we'll walk through ORKA's approach and the implementation details that make it safe. While there are lots of ways to do blue-green in Kafka, they fall into two broad families. A single path approach, where messages flow through either blue or green, versus a multi-path approach, where messages can flow through both applications during transition. Single path makes it easier to preserve ordering and processing guarantees, but comes with state parity difficulties. Multipath, on the other hand, keeps both environments active for state parity, but introduces ordering and processing challenges. So let's dive into both approaches to better understand their trade-offs. In a single path approach, each message traverses either blue or green, never both. The wins are that this makes it easier to keep ordering and processing guarantees. Each message gets processed a single time. The challenges are that application state will naturally become sharded between deployments. Rollback can mean stale or missing state for the other side. And the bottom line is that this approach is easier for guarantees, but operationally tricky when stateful rollbacks matter. In a multipath approach, every message traverses both blue and green. However, only one of them is responsible for outputs downstream. The wins are that both state stores stay warm and testing happens under full load. The challenges are that switching introduces race conditions. You can miss or duplicate messages. Ordering by key may break. The bottom line is this approach is better for state continuity, but riskier for Kafka correctness guarantees. So that brings us to our ideal requirements. In other words, what we want simultaneously. We want three things. We want to keep the application state hot to allow for state parity and rollbacks. We want to keep processing going with no downtime. And we want to preserve Kafka guarantees, no duplicates, missed messages, or reordering. And the reality is most approaches force you to trade off one of these. ORKA's goal is to keep all three. ORKA's approach is to use a multipath strategy with a short drain followed by a switch. Conceptually, we pause both deployments, let them finish their in-flight work up to a synchronized point, then change the traffic rules safety. The key is aligning both sides before the switch, so we avoid duplicates, misses, and out of order behavior. Next, I'll break down the mechanics beyond the pause, sync, and switch. The theme here is that ORKA uses Kafka's normal fetch behavior as a control point, rather than forcing disruptive actions on clients. Kafka consumers request data from a broker via a fetch request. The request includes the topics, partitions, and the next offsets the consumer wants. This is the natural place to intervene if we want a clean, non-breaking pause mechanism. The broker responds with a fetch response containing the next batch, or nothing if there's nothing available. If the response is empty, consumers simply keep polling. Importantly, empty fetches are a normal, healthy condition in Kafka, so we can leverage that behavior. ORKA pauses consumer groups by mimicking the no messages case. When a pause is requested, ORKA empties the fetch responses for that consumer group. Consumers keep requesting the same next offsets and wait naturally until messages are allowed through again. When blue and green are paused, they usually stop at different offsets across partitions. This is due to differing consumer lag. If we change output responsibility while they're misaligned, we risk duplicates, missing messages, or out of order processing. This is precisely the difficulty all multipath approaches must overcome. So the punchline is that pausing is necessary but not sufficient. We also need synchronization to a safe cutover point. ORKA tracks last seen offsets and synchronizes consumer groups after the pause completes. It calculates cap offsets per topic partition by taking the max offset seen across all of the groups. These caps define the finish line. Both sides must reach before we can safely switch responsibility. During sync, ORKA changes pause behavior. Instead of empty everything, it selectively filters fetch responses so that each group can continue processing only up to the cap offsets. This lets the lagging side catch up per partition while preventing either side from moving past the safe switch boundary. Once both blue and green reach the caps and drain in-flight messages, they're effectively synchronized. At this point, we can change output traffic rules without race conditions. This is the exact switch step: safe, deterministic, and bounded. On resume, ORKA simply stops filtering fetch responses. Consumers begin receiving new messages normally, continuing from the synchronized state. Operationally, the disruption is just a brief pause drain interval. So let's recap the outcomes in terms of the original ideal requirements: state continuity, minimal downtime, and preserved guarantees. So ORKA's smart switching set feature lets us do blue-green with only a short pause in processing, on the order of seconds depending on configs. Application state is kept hot, allowing easy rollbacks. And we preserve our Kafka guarantees: no duplicate, missed, or out of order messages. So I'll now move on to a quick demo of ORKA that I've prepared. What I'll be doing now is I'll be recording a demonstration of our smart switching sets feature. So before I dive into the actual demonstration, I'll just describe the setup here a little bit. So I have a control center instance running so that we can take a look at what our apps are doing. You can see here that I have a blue app and a green app, each one of them with 4 replicas, 16 partitions. These are connected to our broker via, you can see here, via ORKA proxy and ORKA controller. So the ORKA system here, they're connecting to Kafka. And what I have is some data in from a data gen that is being sent to the input topics, the same input topic that's being consumed by blue app and green app. So what I'll quickly do here is show you the topics that we have. So I have an input topic that's mapped by ORKA to this physical input topic A, and we have messages coming in regularly. And both of these applications are doing the same thing. They're simply passing through and outputting to a physical output topic. So we can take a look at our applications as well. You can see that they're running here, consuming with very little lag. Again, because they're so simple, they are able to process in real time. Okay, so what I'm going to do is I'm going to walk you through the pause, synchronization, and resume features. So what I'll do is I'll take our blue app, and what I'm going to do is I'm going to create a smart switching set. So I'll do that here. The smart switching set right now is going to contain only the blue application. And the reason I'm doing that is because they're processing with such little lag. I don't want them to be accidentally synchronized when I do my pause. So what I'll do is I'll control that by pausing first one and then the other group. Just before I do that, we can see that they're processing happily. All right. Next, what I'm going to do is I'm going to pause the set. So what we should see is we should see the blue application here begin to show some consumer lag. And not only that, we should see the offsets, the committed offsets stall. Okay. So our committed offsets are not moving. Our end offsets are moving. Our data gen is still pumping information into the input topic. So we can see that our consumer lag is growing and growing. Heading back to the green application is not part of our set. And so its consumer lag is not growing and its committed offsets are growing. So what I'm going to do now is I'm going to add the green application to the same set as the blue application, which will pause it. So now we have our smart switching set that contains the blue application and the green application. You can see now green application is starting to show increasing consumer lag, and its committed offsets are fixed while the end offsets are still growing. The data gen is still sending information into the application. So I have a blue application and a green application. They're both paused. The problem is that you can see that my consumer lag is not the same. So if I were to right now switch the responsibility for sending downstream messages from the blue application to the green application at this moment, I would end up missing or duplicating messages. They are not at the same committed offsets. They are not synchronized. So what I need to do is synchronize these two applications. So what I'm going to do is I'm going to simulate that by calculating what we call the cap offsets. So I'm going to go ahead and calculate the cap offsets. The cap offsets are based on the last seen offsets by each application, which are tracked by ORKA. You can see here that the last seen offsets by topic partition are not the same. We can look at partition 12 just for one example of that. So my green app is ahead. Okay. So if I were to switch right now, since my green app is ahead, I'll miss messages because my green app will start sending downstream, will start processing from here. Okay, so the next step, now that I have my cap offsets, these cap offsets are guaranteed to exist. They're calculated based on our last seen offsets of both applications. So what I'm going to do is I'm going to set those offsets. And before I do that, let me just open these two in two different tabs, and I'm going to sort them by partition so that we can compare them by eye very quickly. You can see here, just taking a look at the current offset, they're not in the same place, but those current offsets are not moving. Okay. So what I'll do, I'll set my cap offsets. And what you'll notice is both applications are going to advance to those same offsets. So now if you take a look, what ORKA has done is it's selectively allowed messages to reach both applications so that they have processed up to the same place and then resumed the pause. So you can see here, blue and green applications are now at exactly the same set of committed offsets. Now, if I do my switch, I can do it in safety. The green application will start resuming from exactly where the blue application left off. So I'm going to go ahead and simulate that resume by resuming the set. Now you'll notice both applications returning to 0 lag as they resume consuming messages, processing. And that concludes our demonstration.